Section 1.4 Part 2 will continue solving applications that deal with the systems of equations. Example 3 says Acme Truck Leasing Company leases a certain size truck for $30 a day and 15 cents per mile, whereas Basic Truck Leasing Company leases the same size truck for $25 a day and 20 cents a mile. So we want to find the function describing the daily cost of leasing from each company. Remember that we're dealing with lines, so we're going to try and write a function that's in the form f of x equals mx plus b. And again, m is our slope. Slope is always a rate of change. So to identify it within an application problem, we're going to key in on the word. So the key word to recognize slope is the word per. So whatever is dealing with the word per is a rate of change, in this case per mile, and that tells me what the slope is. So for Acme, and I'm going to call it A for Acme, we know that it's a certain size truck for $30 a day and 15 cents a mile. So for that company, we know that the 15 cents a mile is our slope times x plus the $30 a day. I'm going to point out that x is going to be the number of miles that you're driving the truck. So in order to figure out how much you're being charged, the number of miles times the 15 cents per mile plus the $30 tells you how much you're going to get charged per day. For the Basic car company, we'll write the same kind of equation. This time it's 20 cents a mile, so that would be 0.20x. They're charging $25 a day. So notice they charge less per day, but they're charging more per mile. X is still the number of miles. So that's the answer to part A. There's our two equations, one for Acme and one for Basic. Part B asks us to sketch those graphs on the same set of axes. You'll notice I'm sticking to quadrant 1. That's because you can't really drive a negative number of miles. So this axis represents the number of miles. This axis up here is the cost. And it's a daily cost. And you're only doing it for 1 day. So it's a daily cost. How much it costs that 1 day to drive that number of miles. We have y-intercepts here, but it would be nice to have a second point that's going on here. I'm going to count by tens, I guess. So 10, 20, 30, 40, 50. I'm literally just going to put in some miles. Let's say we're going to drive 50 miles. I just need a number to be able to do it. It's really hard to use these as slopes to graph that. So for Acme, we're going to let x equal 50. So y would be 0.15 times that 50 plus 30. And that will give me a second point to plot on Acme's graph. So 0.15 times 30, sorry, times 50 plus 30 comes out to be 37.5. So that would be the point 50, comma 37.5. You're saying, well, wait, you need another point. Well, I'm going to use the y-intercept. I know the y-intercept is 30 for Acme. So 30. And by 50 miles, we've only gone up to 37.5. So fairly gentle slope. And it looks something like that. I'm going to label that as A so we know that's Acme. Okay, let's do the same thing for the Basic car company. We're going to let x equal 50, plug it in and see what we get. So y is going to be equal to 0.20 times 50 plus the 25. 2 times 50 plus 25 gives us $35. So 50, comma 35. We'll again use the y-intercept. So our y-intercept for Basic is 25, which is down here. And at 50, we're still a little underneath the other one. Oh, we're at 35. We're a little under the 37. So we can see that it's gaining and we're crossing somewhere out here. We just don't have it yet. So, and that would be B. So that's truck company B. Okay. So now what we need to do is we need to come in and part C, it asks if customer plans to drive at most 70 miles, from which company should he rent a truck for a single day? So part C, if we're going to drive 70 miles for our X, which one? Well, let's just plug it in. Although we should have a guess. The 70 is over on this side, and it looks like B is more expensive. So we think A would be the better choice. Let's see if that backs it up. as we find the value for 70 miles. So for Acme, y would be equal to 0.15 times the 70 plus the 30, and then I'm just going to write both of them on board and then grab the calculator. So 0.20 times 70 plus, in this case, 25. So I'm simply plugging the 70 miles into both of our linear functions to figure out how much each of them costs. So 0.15 times the 70 plus the 30 comes out to be $40.50. That was A, Acme. And for B, we end up with $39, which is exactly what we said should happen. Oh, my graph is really bad. Look at how bad my graph is. So how do I know that? Because my picture shows that Acme should be the better one, and yet numerically we can see they're not. Part of the issue here is the fact that my scale is so tiny compared to what the slopes are. So this is really saying you're going up 15 for every 100, and I only went over 50. So the scale is off, and that's why that looks so misleading compared to this. But luckily we can do the algebra and see that, yes, indeed, Basic Car Company wins. So they're the better choice. So the other type of equation that we need to talk about are the supply and demand equations. So we've done a cost and revenue function. We've done just linear functions that were rental companies. But now let's look at supply and demand. The other big linear function for the business world. So this is example 4. Our last example for this section. Talks about equilibrium, quantity, and price. So it tells you the quantity demanded. So I'm just going to get information on the board. For a certain brand of DVD players is 3,000 a week when the unit price is 485. So 3,000 units when the price is 485. Goes on to tell me for each decrease in unit price of $20. So if I decrease this down, I increase this by 250. So if I decrease this by 20, so if I subtract off 20 and get 465, we then increase by 250 over here. So that would be 3250. And what they did in a roundabout fashion is give me my slope. Here's the change in y over the change in x. So I'm just going to comment that the slope is going to be the decrease in 20 of the price over the increase in units. So in a roundabout way, they gave me my slope already. And again, you did the same thing. 465 minus 485 is that negative 20. 3250 minus the 3,000 is the 250. Now I'm not done with that, but let's get the rest of the information on the board. It goes on to tell me the suppliers will not market any DVDs. So now we're going to go to supply. If the unit price is 300 or lower, will not market any of them. So you're not going to get any units if you're selling them for $300. But a unit price of 525, they're going to make 2,500 available. So a gentle reminder from our previous work that when you're doing supply and demand, that the x coordinate is always the number of units. The price is always your y coordinate. So when I wrote my points, I made sure I put the number of units first and then the price second. They're both known to be linear functions. Okay, part A says find the demand equation. Then we're going to find the supply equation in part B. Well, let's go find the demand equation first. So to get the demand equation, again, we're after y equals mx plus b. We already have m. It's going to be what? A negative 2 over 25. Let's go ahead and make that into a decimal just to make our lives a little bit easier. Remember we talked the other day about the demand having a negative slope, and we just indeed is negative. So this is a negative 0.08. I'm going to come back and use that y minus y1 equals m times x minus x1. So y minus the 485 is equal to our negative 0.08 times x minus the 3,000. And that's an 8. It may not look like it, but it is. Okay, let's distribute. So y minus 485 equals the negative 0.08x plus the double negative makes it a positive. So 3,000 times that 0.08 should be like 24 or 240. Then all we have to do is add the 485 over. So our demand equation is y equals a negative 0.08x plus, so 240 plus 485 is 725. And then the book is not going to call this y, they're going to call this P for price. So the price is equal to a negative 0.08x, where x is the number of units, plus 725. So there's our demand equation. Let's go do the same thing again for the supply equation. This time we do have to find the slope, but they gave me the y-intercept, so they give me a little bit of a hint. So our slope is the 525, that's y2 minus y1, which is 300, all over x2, 2500 minus 0. When I subtract the numerator, I'm going to get 225 over 2500. Let's see if that gives me a nice decimal. We really don't want to go to a decimal if it's a repeating decimal. We'll lose some accuracy and we'll end up with the wrong answer, 0.09. 225, 2500, 0.09. Again, this is our supply. Notice it has a positive slope. We know the y-intercept. They gave it to us. So we know the y-intercept is 300. So our supply equation is y equals 0.09x plus that 300. And again, the book is going to call that P for price. So P is equal to 0.09x plus 300. So there's the supply equation and the demand equation. Now the point where the supply and the demand cross is called the equilibrium quantity and the equilibrium price, the equilibrium point. So again, demand is going down, there's demand. Supply is going up, there's supply. That point right there is the equilibrium point. If you've taken your economics courses, you're going to notice that they use this terminology in that course too. Okay, so what we need to do is to find out, we're going to set these two functions equal to each other and solve for x. So I just need to get more room on my board. I don't know if I've complained about it yet, but I definitely need more board space. So we're going to set supply equal to demand. So our supply equation was 0.09x plus 300. Our demand equation is that negative 0.08x plus 725. And we just need to solve that. So I'm going to add this to this side. That'll give me 0.17x. And I can subtract the 300 back, which is 425. And then dividing that out gives us 2,500. That works out really nice. And that would be the number of units. So this is the equilibrium quantity, is what your book calls it. So let's label that. This is the equilibrium quantity. Then to find the equilibrium price, all we need to do is take that 2,500 and plug it back into either equation, supply or demand. Your choice does not matter because this one's easier to plug into. I'm going to pick it. So y equals 0.09. And why is it easier? Because it does not have a negative out in front of that slope, plus 300. So 2,500 times the 0.09 plus 300 gives us 525. And that would be the equilibrium price. So we just found the point of intersection between our supply and our demand lines. So to answer the question, the equilibrium quantity is the 2,500. The equilibrium price is 525. That wraps up chapter 1 for us. That's all the reviewing of algebra we're going to do. In chapter 2, we're going to come in and look closer at other ways to find those intersection points and come up with some alternative ways when you have more equations to deal with.